Okay, let's take a look at negative and zero exponents. We're going to take a look at the patterns here to see why these properties exist, but in class we'll look at a little bit more of the mathematical background as well. But let's just take it away. 2 to the third is 8, 2 squared is 4, 2 to the first is 2, and then we get here to 2 to the 0th power, and you might be tempted to say that it's 0, but let's watch the pattern. We're dividing by 2 to get 4. We're dividing by 2 to get 2. So when we divide by 2 to get the next term, we end up with 1. 2 divided by 2 is just 1. So we find that 2 to the 0 is just 1. We'll come back to that in a moment. Let's keep going though. We're going to divide by 2, we get 1/2. Divide by 2, we get 1/4. Divide by 2, we get 1/8. Okay, so we start to see that there's a lot of relationships here. This is 1's like our center, and then we go 2, 1/2, 4, 1/4, 8, 1/8. So they're really reciprocals of one another. And that's going to lead us into some of the rules of negative exponents. Okay, so first rule that we've learned here is this right here. 2 to the 0 is equal to 1. Anything to the 0th power is equal to 1. And it says here, for any non-zero number a to the 0th power is equal to 1. So that means x to 0 equals 1, y to 0 equals 1, 1 million to the 0 equals 1. Now there's only one requirement though. It says it can't be 0, any non-zero number. And that's because 0 to the 0th power is equal to an error. Okay, so that's the first rule. That's the one that's pretty straightforward. The second one's a little bit harder to decipher, so I'm going to write it over here. We saw that 2 to the negative first is equal to 1/2. Then we saw that 2 to the negative second is equal to 1/4, and then 2 to the negative third is equal to 1/8. Okay, so I can really write 1/4 is 1 over 2 squared, because 2 squared is 4. And 1/8 is 1 over 2 cubed, because 2 cubed is 8. So what we start to see is that whenever we have this negative exponent, all it does is it throws it into the denominator. So 2 to the negative first is 1 over 2 to the first. 2 to the negative second is 1 over 2 to the second. 2 to the negative third is 1 over 2 to the third. So whenever we have negative exponents, it just puts it into the denominator with a positive. So the rule here is for any non-zero number a and any integer n, a to the negative n equals 1 over a to the positive n. That sounds like an awful lot, but here's what's happening. If you have x to the negative 3, that's the same as 1 over x to the positive 3. If you have y to the negative 5, that's the same as 1 over y to the positive 5. If you have, let's take a number, 10 to the negative 7, that's the same as 1 over 10 to the positive 7. And we'll also look at some of the calculator work with new numbers so to see that this actually is the same. We'll type in 10 to the negative 7th, then 1 over 10 to the 7th, and they will be equal. They're exactly the same. Okay, so let's practice with example 1. Write the expression using only positive exponents. Okay, 5 to the negative second is the same as 1 over 5 to the positive second. And we can simplify that if we'd like. But we're really focused right now on just the practice of recognizing that negative throws it to the denominator. Then we have 1 million to the 0, and we said anything other than 0 to the 0 is 1. Here we have 3y to the negative second. So I'm going to focus just on my y to the negative second, and that's going to give me 1 over y to the positive second. And then I have this 3, this coefficient of 3. Well, that's really 3 over 1. So that 3 is in the numerator, so it has to stay in the numerator, because that's not affected by that negative 2. We have a to the negative 7th, b to the 3rd. So we're going to take it in terms, pieces. A to the negative 7th is going to go in the denominator and become a to the positive 7th. B to the 3rd is positive, so it just stays up top. B to the 3rd over a to the 7th. Let's do the u try. X to the negative 5th is 1 over x to the positive 5th. 0.123456789 to the 0 is equal to 1. Here we're going to take it in pieces. A to the negative 5th goes in the denominator, becomes a to the positive 5th. And b to the 0, again, anything to the 0 power is just equal to 1. So that whole thing just disappears, and we have 1. Okay? Here we're going to do it again in pieces. So the 4 is in the numerator. M to the negative 4th, denominator, becomes m to the positive 4th, and n to the 3rd, numerator, because it's positive. Okay? Let's try the next page. Write the expression without using a fraction bar. So what we want to do here is factor these into their prime factorizations and then take care of the exponents accordingly. 25 is the same as 5 squared, so this is really 1 over 5 squared. And now to bring this 5 squared up, because I want it without a fraction bar, I have to write it as 5 to the negative second. And I could work backwards to check to make sure that works. 5 to the negative second is same as 1 over 5 to the positive second. Okay, 100, I can break it into, we'll just do 10 times 10. So it's 2, 5, 2, 5. So really my factorization is 1 over 2 squared times 5 squared. Well, I want to bring each of these up to the numerator, so I'm going to write 2 to the negative second, 5 to the negative second. And there you have it. Okay? 1 over 4 is 1 over 2 squared. The way to bring this 2 squared up is to write it as 2 to the negative second. 1 over 9 is 1 over 3 squared. So the way to bring that up is to write it as 3 to the negative second. Letter A, 1 over 49 is 1 over 7 squared. So the way to bring that up is to write 7 to the negative second. 64 is going to break apart into a lot of things. We're going to have 8 and 8, which is 2 times 4, 2 times 4, and that breaks into 2's as well. So really, 64 is the same as 2 to the 6th, because we have 6 2's. And we want to factor that so it becomes 2 to the negative 6. We want it without a fraction bar. 144 is 12 times 12. So we already saw up above. Oh, no we didn't. 12 would be 3 and 4, and then 3 and 4. And that breaks into 2's again. So we find that 144 is 1 over 2 to the 4th, 3 squared. But I want it without a fraction bar, so I have to bring each of these terms up to the numerator. So 2 to the negative 4th, 3 to the negative 2nd. Last one is 81, which is 9 and 9, or 3 and 3. So 81 is really 1 over 3 to the 4th. 3 to the 4th, to bring it to the numerator, is 3 to the negative 4th. And there you have it. They're exactly the same thing. A little bit more and we're done. Write the expression without using a fraction bar. So the numerator is going to stay where it is. The 3 stays up there. To bring this x to the 5th up, it's x to the negative 5th. Letter B, 5 stays where it's at. To bring this n to the 4th up, n to the negative 4th. Letter C, x to the 7th stays where it's at. To bring z to the 2nd up, z to the negative 2nd. X to the 4th is going to stay where it's at. It's already in the numerator, and I want no fraction bar, so I want everything in the numerator. To bring up y to the 3rd, it's y to the negative 3rd. In the u-try, 4 is going to stay where it is, and it becomes b to the negative 5th. We get h to the 4th, g to the negative 3rd. Now the only thing here is you usually want it to be in alphabetical order, as we've had in all these problems up above. So you would rewrite it as g to the negative 3rd, h to the 4th. Letter C, we get y to the 7th, z to the negative 5th. And letter D is x squared, y to the negative 3rd, z to the negative 4th. And you're done. Nice job, guys.